Alright, in this video I'm going to show you the other two ways that the discriminant or simplifying the radical in these steps will show themselves. So we already did example 1 in a different video, and that example 1, after I simplified the radical all the way down, it turned out to be a whole number. In example 2 and example 3, they're going to turn out to be a little bit different than whole numbers. Like in example 1, I'm sorry, it was a perfect square underneath the radical after you simplified the discriminant, and again we'll talk about that. In example 2 and example 3, they will not be perfect squares. So I just want to show you what you do at that point of that situation. So again, I will take this step by step for number 2. The first step is to put this equation in standard form. If you remember correctly, standard form of any quadratic function is ax squared plus bx plus c equals 0. Now, in number 2, I have my quadratic term here that matches my quadratic term here. I have my c term here that matches here, but I am missing my b term. In this case, my b term is on the other side of the equation. So, if in standard form it's always the quadratic term, then the linear b term, this. So I need to move this piece, the 4v, over here, and I need to stick it in the middle between 5v squared and 8, because standard form is always the quadratic term, x squared, then the linear term, x, and then the coefficient c. So in order to do that, it is another clue that tells me is that it always needs to equal 0. Any quadratic function, when you're solving it, needs to equal 0. This doesn't equal 0. It equals 4v. So I need to move that 4v. It is a positive 4v, so I'm going to subtract 4v from both sides, on the right-hand side and the left-hand side. Now, subtracting it on the right-hand side cancels it out. And over here, there is no linear term. There's no v over here to combine it with, because there's v squared but not a v. So then, I can just rewrite it. So my first step, again, is to rewrite in standard form. 5v squared, my quadratic term, goes first. Then my linear term, 4v. And then my coefficient of 8. So I have rewrote it in standard form. And again, it equals 0 because the positive 4v and the negative 4v cancel each other out. So that is the first step. You need to be able to know how to do that even when you're factoring on the test, because chances are they won't always be written in standard form. You might have to move them around a little bit. So my second step is identify the values for a, b, and c. So I will do that. My second step, a equals 5. Remember the quadratic term, the coefficient there. B equals a negative 4, and c equals 8. Please, please, please remember that if it's ever a minus a number, it has to be negative, that negative number. Alright, so it's a negative number. Now, my third step is to input the values into the quadratic formula. I'm referencing this quadratic formula up here, where it's x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so opposite b. I say opposite b because that's just easier to recognize. So I'm going to put x equals opposite b. My b in this case is a negative 4, so it's going to be a positive 4 because it's opposite b in that position. Plus or minus the square root of, in parentheses, back to my original b, which is a negative 4. Please put that in parentheses or you'll get a wrong answer. Squared minus 4 times my a, which is 5, times my c, which is 8. 4 times 5 times 8. All over 2 times a, which is 5. At this step, then, I've entered it in correctly. That's step 3. So I've done 1, 2, 3. Step 4 is simplify the discriminant and rewrite the formula with the new radical. The discriminant exists underneath the radical, here. So I can use my calculator to simplify that. So this discriminant simplifies down to the square root. Again, don't put the square root in your calculator. Just put the numbers underneath it exactly as is. So parenthesis negative 4, close parenthesis squared, minus 4, parenthesis 5, parenthesis 8. That breaks down to negative 144. So at this point, something jumps out at me. I'm taking the square root of a negative number. So that should tell me at some point my final answer needs to have an I to tell you that you've entered into the realm of imaginary numbers. So I've simplified the discriminant. Now I need to write the quadratic formula, rewrite everything with my new radical. So 4 plus or minus the square root of negative 144 all over 2 times 5 is 10. All right. Now, the square root of negative 144 can be broken down. If you remember, always check the positive version to see if it's a perfect square. If I take the square root of positive 144, it is 12. So the square root of positive 144 is 12, meaning that I can go down here. X equals 4 plus or minus. The square root of positive 144 is 12, but I'm taking the square root of a negative here. So again, whenever I take the square root of a negative, I need to put I to indicate that I'm entering into the realm of imaginary numbers. So it's 4 plus or minus 12i all over 10. So I just did step 5. I simplified. So I rewrote in step 4 and step 5, I simplified the radical if necessary. It definitely needed to be simplified. It simplified from negative 144 to 12i. Now my final step, step 6, is to simplify the expression if necessary. So I'm left with this expression right here. X equals 4 plus or minus 12i all over 10. Now, in this case, I see whole numbers here, here, and here. They are all even, so I know that they can be reduced by a factor of 2. So I can write x equals 4 divided by 2 is 2, plus or minus 12 divided by 2 is 6. Don't forget your I. All over 10 divided by 2 is 5. And I am all done. Go ahead and try number 3 on your own. I decided to let you try that one on your own first, and then raise your hand when you're done so I can come check your work. Remember, the first step is to put it into standard form. It looks to me like I need to move 2 things over to the right-hand side. One is positive, so I would probably subtract it, and negative 10n is negative, or minus 10n is negative, so I'd probably add it. Go ahead and try it. Raise your hand if you need help.